There's no additional vocabulary for 3-4, so just the problems here. So what are the solutions of 9 plus 4t is greater than 21? Check the solutions. So if you remember correctly here, when we add or subtract, it doesn't change the inequality symbol at all. Nothing at all changes. So my solution here, I go ahead and subtract the 9 from both sides. So 4t is greater than 12. Divide the 4, and t is greater than 3. Nothing changes. And again, you can do the check. Check that 3. Check some other numbers back before and after 3 and see if they work or don't work accordingly. So here, again, just like good old-fashioned two-step equations, I'm going to start out by adding 7. Negative 6a is less than or equal to 7 plus 17 is 24. Divide off my negative 6, divide off my negative 6. Boom, I divided by a negative. Inequality symbol switches. So a is greater than or equal to negative 4. So again, be aware of that fact. When you check it, check the negative 4. Check negative 3. Check negative 5. Alrighty. Here, we're going to go ahead and start off by subtracting the 5 from both sides. And we get negative 9 is less than negative 3. And again, don't lose that negative in front of the 3. Divide off that negative 3. And as soon as I do that, flip the inequality sign. So 3 is greater than, well, n. Which, again, I don't like the way that looks. Use your mirror trick. N is less. Oops. That's not an n. Whoopsie. There we go. So we get n, there we go, so hard to write, is less than 3. Gosh, I don't know what happened there. Alrighty. And then some decimal fun. We all know we love that stuff. Start off by subtracting 30 from both sides. And we get 20 is greater than 0.8x. Divide off that 0.8. And we get 25 is greater than x. So again, putting the variable on the left side, x is less than 25. That's what we're looking for. Writing and solving a multi-step equation. In a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. You have at most 42 feet of fence. What are the possible lengths of your garden? So area is obviously, perimeter is 2 the lengths plus 2 of the widths, right? So length, width, right? So at most means that we have to be less than or equal 42. I don't have more than that. I have up to that, but not more than that. So 2 lengths plus 2 widths. Now here's the thing. I already know that my width is 12. That's set, right? So 2 lengths plus 24 is less than 42. Subtract the 24, 2 lengths is less than 18. Divide the 2, and the length is less than 9. Obviously, this is one of those, well, it can't be 0, right, and it can't be a negative number. So the length of the garden must be 9 feet or less, is what we're looking for our answer there. Alrighty, so kind of like the last one, you want to make a rectangular banner that is 18 feet long. You have no more than 48 feet of trim for the banner. What are the possible widths of the banner? So let W equal width. Okay. So we have, again, we know 2 lengths plus 2 widths. We want to be less than or equal to 48. Because I don't have any more than that. 48. There we go. So 2 lengths. The lengths are going to be 18 foot. So 2 times 18 plus 2 of the widths less than or equal to 48. 2 times 18 happens to be 36. 36 plus 2 widths is less than or equal to 48. Subtract that 36. The 2 widths have to be less than or equal to 12. Divide off the 2, and the width is less than or equal to 6. 6 feet at most for the width of the banner. So that's what we're looking for. Anything in between, from 1 foot all the way up, right? It's up to you. Distributive property fun. It works just like it does with regular numbers, folks. So I start out with this, distributive property. Always distribute first. You know your order of operations, right? We've discussed that, gone into that at length, I believe. So here, distributing, first off, 3t plus, now some folks, again, this is 3t, 3 times 1. Not 3t plus 1, you've got to 3t plus 3. Some of you are still messing that up in the last quiz, so let's stop doing that. Then we go back and combine like terms. 3t minus 4t is negative 1t, plus 3 is greater than or equal to negative 5. Go ahead and subtract the 3 from both sides. The opposite of t, or negative t if you will, is greater than or equal to negative 8. Now once I divide off that negative 1 in front of the t, I flip the inequality symbol. Really important. Don't forget that. So t becomes less than or equal to 8. So in this case it was a. What is the solution of 15 is less than or equal to 5 minus? Now let's do this one real quick here. Or not quick, maybe. So we're going to have, again, 15, whoops, there we go. 15 less than or equal to 5 minus 2 times 4m plus 7. Now, we're going to distribute a negative 2. Please don't forget that. So we're going to have 15 less than or equal to 5 minus 8m minus 14. I need to combine some like terms here before I go any further. So we're going to have 15 less than or equal to 5 minus 14, I believe, is what? Negative 9 minus 8m. Now we can go ahead and we can add the 9 to both sides. So adding that 9 to both sides, gives us 24 less than or equal to negative 8m. Now I'm going to divide a negative 8 on both sides. So I flip the inequality before I forget. 3 is greater than or equal to, or negative 3 I should say, is greater than or equal to m, which again, using your mirror trick, means m less than or equal to negative 3. That's what we're talking about. A little bit extra to remember, not a lot, but a little bit extra to remember with these. Alrighty, continuing on our quest for solving fun stuff. Solving inequality with variables on both sides, no different than we've been doing, folks. So taking a look here, obviously we're going to go ahead and try to move variables to one side, move the numbers to the other side. In this case, we're going to start by moving the 3n over here by subtracting it from both sides. Then we're going to move the 1 over here by adding it to both sides. And then we're dividing by a positive, so we don't flip anything. So solutions here, we have 3b plus 12 greater than 27 minus 2b. I'm going to move that 2b to the left side by adding it to both sides. 2b or not to be, right? A little Shakespeare fun there. So you didn't know math could be so educational, did you? So we get 5b. That's not really a very good 5. What the heck? Alrighty. b. Alright, there we go. 5b plus 12 greater than 27. Subtract the 12 from both sides. 5b greater than 15. Divide the 5 again, dividing by a positive, no need to flip anything. B is greater than 3. And when you check 0, check 3, check 5, whatever works there for you. And then B, reasoning. The first step in solving problem 4 was to subtract 3n from each side. What else could you have been your first step? Lots of other things, right? You could have added 1 to each side, right? So moving the constants first, that sort of thing. That's it. Hey, guess what? Special solutions time, right? Those infinitely many or all real numbers or no real solutions. Yep, it applies here too. What are the solutions of 10 minus 8a is greater than 2 times 5 minus 4a? So here's the great thing. Distributive property first. 2 times 5 is 10. 2 times negative 4a is negative 8a. Now here we recognize that it's the same thing on both sides, right? Literally the exact same thing. But if you didn't, add 8 to both sides. Or 8a, I'm sorry. You get 10 is greater than or equal to 10. Well, that's true. 10 is always equal to 10. So it's always true. All real numbers make this thing work. Just like before when talking about all real solutions. Take a look at this one. We start out by, let's see here. We're going to clean things up a little bit on the right side. We're going to subtract the m, we're making 6m. So 6m minus 5 is greater than 6m plus 5. So again, combine like terms up here. Subtract the 6m from both sides. Alrighty. So on here we get negative 5 is greater than 7. Never, ever, ever a true statement. Now if it came out 7 is greater than negative 5, that's always true, right? But in this case, it's never true. Negative 5 cannot be bigger than 7, so we know there's no numbers. You can try all you want. No numbers you pick that would make this a true statement. Alright, so to finish up this one, these two rather here, let's start out by subtracting 9 from both sides. And we get 5n is less than or equal to 5n minus 10. And then we subtract the 5 and, guess what happens? It disappears, so I get 0 is less than or equal to negative 10. Well, since 0 is never smaller than negative, is not smaller than negative 10, it'd be smaller than 10, but not negative 10, this would have no real solutions. And then on this one over here, we're going to start out by cleaning up the right side. So we get 8 plus 6x greater than or equal to 6x plus 2, right, because 7x minus 1x is 6x. And then let's say we decide to subtract the 6x from both sides. So we get 8 is greater than or equal to 2. Well, 8's always bigger than 2, so we find out that every number is going to work. So when you get an always true statement, be careful on those. Double check your math to make sure when you're done with those two.